Okay, before we get started on the last Regents in the Green Book, I just wanted you to take a look at last year's scale. If you take a look at this right here, right, that's a 65, which is passing on the Regents, right? So you need a raw score of 28 out of 86. So if you converted that to a percentage, that's about 33%. Okay? That is 14 part one questions. I know you can all get 14 right on part one. And do show a little work, make sure we show some work in the part twos and threes and fours to get some partial credit if necessary, right? Because you should know, even with the stuff that we didn't cover, there's enough points available for everybody to pass this Regents. So, take a good look at this. There's some that have been coming over and over again, and they probably will be on this year's Regents as well. Okay, so with that said, let's look at the last one in the Green Book. Okay, the first question was a food manager studied the lunchtime eating habits of a group of employees in their office building. The purpose of the study was to determine the proportion of employees who purchased lunch in the cafeteria, bought their lunch from home, or purchased lunch from an outside vendor. This collection of data would best be classified as an observational study, right? They observed the people who had lunch in the room, and they checked it out. So one like this, even though we didn't do statistics, you could pretty much know just from common knowledge what this should be. The second question is, which graph has imaginary roots? Imaginary roots do not touch the x-axis. If you have a parabola, if it doesn't touch the x-axis, there are no roots, right? So they have to be imaginary. There are no real roots, we should say. So they're imaginary. So this is number 2. Number 3, it says 3 is a given 3 is a root of this x to the 4th minus x to the 3rd minus 21x squared plus 45x. What are the other unique roots? Well, they give you the choices here. So the best thing to do is to use your calculator. So I'm going to pull up my calculator and put it in the y equals screen. And wherever you get y is equal to 0, that's where the roots are. Or you can actually see them on the graph. Remember, the first part, you probably don't have to change the scale. There's one coming up that we have to look at it, but we should be able to figure it out. All right, so here it is. So you go y equals, let me clear this, right? And we put in x to the 4th minus x to the 3rd, x raised to the 3rd, it's above the divided by button, minus 21x squared plus 45x. I mean, this one would be, you could factor it, but, let's just take care of this way. All right. You should probably be able to observe that 0 is definitely going to be one of the roots, because if you put in 0 for all the x's, you're going to get 0 for y. Right, so that's one of the roots. So now let's look at the graph of it. And you can see, I can't write on this, but you can see there's a root at -5. It crosses the x-axis. At 0, it crosses the x-axis. And at 3, it just touches the x-axis. So those are the roots, right? So we have a root at -5, at 0, and 3. So let's go back. Right. We had one at -5, right? We had one at 0. We actually had 2 at 0 because it's tangent to it. You got to remember that later on, right? When it just touches, it doesn't cross, it means it's tangent, and there's actually two roots there, or 2 factors that we have to watch out for. And x is equal to 3, right? So this one's no good, right? This one's not in there. It's not 5 only, it's -5 and 0. These were the two that weren't given originally. And number 4 is just your basic log equation, right? The base of the equation, right? Just think about it. The base is 1/2, right? It's the number being raised to the exponent. The exponent is q, right? And the answer is p, right? So the way this looks, it's log base. This is the answer. This is the answer, and it's equal to the exponents. Logs are exponents, right? So if we put those into that equation, right, the exponent is q, is equal to log. The subscript is the base, which is 1/2, and the answer is p. So this is choice number 3. All right, which of the graphs best represents the graph of x plus a times x minus b, where a and b are positive real numbers? So with a and b being positive real numbers, we kind of know that our general cubic equation goes like this, comes up from the bottom and then does this, right? That's our basics. So right away, we know it's not 3 and 4, right? If they said a was negative, then it would be different. Then it would be the opposite. Now the other thing, there's two of these, x plus a, x plus a, and this is x minus b, right? So it's the same thing. X has to be equal to -a, x has to be equal to -a, right? And x has to be equal to b, which is positive. Now, since there's two -a's, that means it's tangent to it. And this is the one that's tangent. It just touches a negative number and then it goes back down. This one we have there's 3 different roots, not a tangent. Okay, so this would be -a here, and there's 2 of them. And this point here would be positive b. So this one is number 1. All right. If I go too fast, just pause it and do it. And, at your own pace. This one here I also did on my calculator, right? So we want to find the intersecting point. Now, here's the one that really, bugs me, right? The equation y is equal to 3x plus 6 is equal to y equals 1.82x raised to the t, right? I'm going to call them x's because we're going to put them in x's in our calculator. Approximate the model of the growth of 2 separate populations where t is greater than 0. Okay? T is greater than 0. That means it has to be a positive number. What is the best approximation of time t? Okay, so right away, 1 can't be an answer because it's negative. So now if you're going to guess, you kind of just, improved your odds by 25%. But let's look at this on a calculator. Again, I didn't change the window. I'm sorry I can't get a TI 84 on this, but let's go back to this. Let's clear this one and let's put in 3x plus 6, and let's put in parentheses 1.82 raised to the x power. Okay, now if we graph these, here's the problem, right? So you see this one here, and if you look on the TI-30, the TI-84, the -2 can't be an answer, right? That's that -1.9, and when you look at it, you're like, oh yeah, there's the intersection point, but they don't want the negative. They actually, it's kind of cool with this calculator because I can actually scroll over and down, but we need the one that's up here. It's somewhere between 4 and 6, right? You can see it starts turning up, and there has to be another root. It's further up on your TI-84 because I did it earlier on the TI-84. So what you do is, you know it can't be this negative number, so you go second, calc, right? Do the intersection, right? Now, move that little cursor. See, I have my cursor all the way up here. When you get yours, it's going to be down here somewhere, right? It's going to be closer to this. And if you enter it here, it's going to give you that negative 1.9. You'll think you have the answer, but they're not looking for the negative. So just move it way up here as far as you can. Go up past 4. You know, even there, you can still see it on your screen. You don't know where it is yet. And then you just hit your enter 3 times. Right? So mine said no intersection, but let's do it again. Second, calc. I think this is a little different. I think I have to move it twice. Right, my left bound, and then I'm going to move it way up here to the right. Right bound, enter. Anyways, on the TI-84, I got 5.1 something, 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 right? So it was choice number 3. All right, it just keeps saying no intersection. I don't know why, maybe because I don't have my window set right. But if you do it, it'll come out on your TI-84. All right, so this one was number 3. Just done on your calculator. So far, I mean, really, we can't get those 6. We got 6. We're almost halfway home already to our magic number of 12, I think I said, or 14, right? All right, here we go. Given y is equal to 2x and x squared plus y squared is equal to 5, the point of intersection quadrant 2 is. Now, you know, you can plug these numbers into each one of these and see which one gives you both correct for both of these, right? So in other words, you're sitting there and you don't know what to do at all. Well, you have an x and a y, right? The coordinates are x and a y. Start plugging them in, right? If we do choice number 1, I'll do one that doesn't work, right? Negative 2 is equal to negative 2 times 1. That works there, right? That's checked. But how about in the other equation? I have 1 squared, you know, and that's a circle equation, if you remember, plus negative 2 squared is equal to 5. Right, this becomes 1 plus 4 is equal to 5. But the problem with this one is it's not in the second quadrant. Okay? So I really didn't even have to do that one. Right, that's not in the second quadrant. It has to be a negative and a positive. So let's try 2, right? Negative, this is 1 is equal to negative 2 times negative 2, right? That doesn't work. The one that does work for both of them is 2 is equal to negative 2 times negative 1, right? That's 2 is equal to 2. And if we put in the circle equation, we have negative 1 squared plus 2 squared is equal to 5. This becomes 1 plus 4 is equal to 5. So that checks. Now, you can also plug it in and do it. You could also plug in negative 2x for y, right? So you could do 2x. I'll just do this. This is an alternate way. I mean, you know, when you have numbers in your answers, all you got to do is plug and chug. Really just plug and chug. But let's look at this. So what I did algebraically is I took this negative 2x and I put it in here for y. So I had x squared plus negative 2x squared is equal to 5, right? This becomes x squared plus 4x squared is equal to 5. You combine like terms, you get 5x squared is equal to 5. Divide by 5, divide by 5. And you get x squared is is equal to 1. Take the square root of both sides, you get x is equal to plus or minus 1. Right, now here again, you got to remember it's in the second quadrant, so that means positive 1 didn't work as we saw before. And then you would just take the negative 1, right? Y is equal to negative 2 times negative 1, and you get y is equal to 2. Right, so you end up with the same answer, just algebraically. All right, so those are the two ways you would do this. The next one is a rational expression is equivalent. Now, look at your answers. All these look like remainders to a long division question, right? They all look like, so, use that when you're doing the test. Right, we're going to see in a couple of minutes, there's one where you're going to simplify, and we'll see the difference between the two. But usually, if you're going to do long division, there's going to be a remainder with a number under it. Right, with the divider, divider under it, right? So let's do the long division. And do you have to do, well, yeah, I guess we have to do long division because we don't know. We have 2, let me change this. We have x minus 3 and 2x to the 4th. Now, this one's missing a x cubed term, so how do we take care of that? We put in 0x cubed, right, minus 5x squared plus 3x minus 2. One day you're going to see your children doing this when they're in the 11th grade. You're going, oh, yeah, I remember how to do that, right? All right, so 2x to the 4th divided by x is 2x cubed. Now we're going to multiply this. So 2x cubed times negative 3 is minus 6x cubed. And this becomes 2x to the 4th. Now we're going to change the signs, right? So this becomes a minus, and this becomes a plus. So now we have 6x cubed minus 5x squared. All right, 6x cubed divided by x is positive 6x squared. All right, you could see, you could check with your answers, right? So far we have one term, we have 2 terms, right? So far we got these 2 terms. These 2 we don't have. Right? Actually, we don't have this one either. We could even stop right there, probably, if we have confidence. All right. So 6x cubed divided by x is plus. Wait. Oh, wait, I got to do the multiplication. I got so excited we had the answer already. All right, so this is my x. 6x squared minus 3 is minus 18x squared. This is 6x cubed. Change the signs, minus and a plus. This becomes 13x squared. Right, we're going to bring this down. Right, plus 3x. If we divide 13x squared by x, we get plus 13x. Okay, and then if we multiply this out, I get 13x times negative 3 is a negative 39x, and this is 13x squared. Change the signs, and we get 42x. We're going to bring down this last little guy, negative 2. All right, so this is going to be plus 42. This is negative 126. This is 42x. Change the signs. And this is 124. All right, so this is plus the 124 over the divisor. All right, so this was choice 2. All right, so we're up to 8. You should all get that one right too. Number 9, our old domain. This one had a little wiggle waggle in there, which kind of upset Mr. Siegel, but we'll see what happens. Right? So, a focus. Right? So I'm going to draw a little coordinate plane, right? Our focus is at -3, 1, 2, 3, 2. That's our focus. It's inside the parabola. And our directrix is the y-axis, right? It's this axis here. This is y equals 0. Okay, that means our parabola comes down halfway and goes up and goes up. Okay, it's kind of a crappy drawing, but anyways, so this is our vertex. If this is -3, 2, there's 2 units between here and the directrix, right? There's 2 units here, and it has to be equal distance. So this has to be 1, and this has to be 1. So that means our vertex has to be -3, 1. Okay? So now look at your choices. And remember, you have to change the x-axis. These are all in vertex form, all of these choices, right? So you have to change this, change the x, and keep the sign of the y, right? So these 2 are okay right now, 1 and 3. And these 2 are not okay because they didn't change the sign of the x. Okay, now, so then what I did was I looked on my calculator and I found the y-intercept, okay? And the y-intercept, I just put them in. I put them both in. Let me put them both in. We'll go to a table and just talk about it for a second. Or I'll talk about it, you'll listen, or whatever. All right, y equal, let's clear this one. Let's go up here, clear this one. All right, if you put in 0.25, right, x plus 3 squared plus 1, okay, and then you put in 1/8. You could put it in as a fraction, but that's 0.125. X plus 3 squared plus 1. And you graph these 2. I'm going to try to change my window, -10. I really don't like this one, but anyways, let's look. Go back to y equals, right? I got these 2 in. Oh, 1, 2. Graph. These aren't even them. This is, don't buy this app. This is not an endorsement for this app. This app stinks. Let me try another one. What other one do I have? Oh well, if you put it, let's just go back here. If you put it in there, right, the wider one comes down here. The other characteristics of the directrix and and they're the same distance. So this one came out to be like 2 something, but this one was over 3, and this is over 3, right? So it has to be the first one. The y-intercept was big enough. This one, the y-intercept came out to be like 2 something or 1 something. It's not long enough because these distances have to be the same. All right, let's go on so we can finish this up. Number 10. So what I did with this one was I tried to figure the common ratio, and the best I could do was a pattern, right? This becomes -2, 2, negative, then we multiplied by 2, right? So let's talk about, so this is 1, 2, 3, 4. The fifth one's going to be 4, and then the 3 changes to 3, 6 to 3. So this is 4 square root of 6. Okay, and then it's multiplied by another -2. Right, so now I have -8, and the 6 becomes a 3. It alternates back to a 3. And then the 7th is the +8, right? Because it's 1. There was probably a -1 there, but -2, 2, -4, 4, and then multiply by 2 again, -8, 8. And then the alternate is the 6. All right, so this one was choice number 3. All right, now here's a standard deviation problem, which if you see this number 95, right, or you see half of that number, right, what that means is 95%, 2 standard deviations. It has to say, okay, also it has to say is normal distribution. All right, 2 standard deviations is in each direction. Plus or minus 2 standard deviations is 90%, 95% of the data. Okay, so this is nothing more, right? If they give you the mean and the standard deviation, they say what's within 95% of the data. It's nothing more than taking the mean, right, and adding 2 times the negative standard deviation, right, and taking the mean and adding 2 times the positive standard deviation, because in this 2 standard deviations, this is 1 standard deviation in each direction, right? Within all this is 95%. All right, so this came out to be 12.62, and this one was 7.02. Okay, now basically the way I look at it is, this is the first one. Maybe a 10 is from 9th grade. The first one where, we didn't do it and we didn't see it several times as we're going on through here, as we went through the review. This, so we have 10 right, and number 12 we should be able to do too. Now, here's the difference. Remember, this is division of polynomials, right? This is the 2x squared plus 7x minus 15 divided by 3 minus 2x. Now, look at all your answers. They're polynomials. So this one means we're going to simplify this. That's exactly what this means. So we're not going to divide it. It's going to be simplified. Okay? So to factor this, so we got to factor. To factor this first one, we have to do the rainbow method. So this is -30. So I need 2 numbers that multiply to be -30. And I need the 2 numbers to add up to be +7. Okay, so those 2 numbers are 10 and -3. So I'm just going to work down here, right? So I have x plus 10. And I'm just going to do the numerator for now, and in a second I'll throw in the denominator. Let me erase it and move it over. I ran out of... Right, so I have x plus 10 x minus 3, but don't forget to pay back the rainbow, right? So we got to divide both of these by what we multiplied by, right? We did 2 times -15 here. So now I got to pay back the 2. So this is x plus 5. And this one is 2x minus 3, right? Because it's not equal. And then we're going to put in the bottom, we're going to put in, the denominator is this 3 minus 2x. All right? So these the 2x minus 3 and the 3 minus 2x are the same but opposites. So this cancels out and becomes negative 1. So if you distribute the negative 1 here, you get negative x minus 5, which is choice number 1. Okay, so that's 1/2 of the multiple choice for this one. Like I said, as you know, we're almost to the magic number already, and we haven't done, too much really crazy stuff. All right, so go through those slowly, see if you understand them, email me. I'm sitting out here on my deck. It's beautiful. Enjoy Juneteenth, day off, and I'll see you soon. Bye.